Good afternoon. I am pleased to be with you today and to have the chance to introduce our next speaker in the Empire Lecture Series, Jamie Druckman. My name is Ben Gaskins, and I'm an assistant professor of political science at Lewis and Clark College. And I know Jamie a little bit, mostly by reputation and via my advisors, but I had the chance to work with him a little bit at a conference at Northwestern on experimental methods. And he's both one of the best, smartest political scientists and also a very nice guy. So I'm very excited to be here introducing him today. Jamie Druckman is the Payson S. Wild Professor of Political Science and Faculty Fellow at the Institute for Policy Research at Northwestern University. He is also an honorary professor of political science at Aarhus University in Denmark. His research focuses on political preference formation and communication. Druckman's work has been recognized with numerous awards, including over 15 Best Paper and Book Awards. He has also received grant support from the National Science Foundation, the McKnight Foundation, the Russell Sage Foundation, and Phi Beta Kappa. 2012 was a very good year for Druckman as he was elected to the American Academy of Arts and Sciences and received a John Simon Guggenheim Memorial Foundation Fellowship. Today, his topic is Do Politics Hinder Scientific Communication? Please join me in welcoming Jamie Druckman.
As Ben said, the title of the talk is Do Politics Hinder Scientific Communication? So I'm going to start putting it in kind of a broader context, and then I'll kind of give you a roadmap of where I'm going, and I hope to not take more than about 25 minutes, and so we can have some discussion, and because I'm looking for that a lot. A lot of this is foundational work for a project that Skip Lupi and I are starting to pursue, so, and he's here, so he'll answer all questions. And so if we stand back for a second, governments, when we think about what governments do, governments often provide public goods that wouldn't otherwise be provided for the market. They make laws, they distribute resources, and so on and so forth. So in doing so, public officials draw on a lot of different sources for information and input. Two of those sources are science is one, right? And we can see that from the investment in the National Science Foundation, the NIH, the National Academy of Sciences is there to advise government on matters of science. And then a second source of input is citizens' opinions. And so the question of how science influences public opinion therefore affects public policy with regard to science, what government's going to do when it comes to the content of scientific policy, and then also citizens' behavior themselves and ultimately their well-being. And we can all think about various areas of science and technological evolution that affects us directly. So scientific communications shape what people think and believe and how they behave. So therefore, the question that I'm asking here, the larger question is, do aspects of political context hinder the effectiveness of scientific communications? That's kind of the large question that I'm trying to get at here. And so how am I going to do that? I'm going to start by going through three political realities of the scientific communication environment: media saturation, partisan polarization, and the politicization of science. I'm then going to talk about three ways in which these contexts might have what we might think of troubling opinion formation processes. And these are the psychological processes I'll talk about: the availability heuristic, partisan motivated reasoning, and status quo bias. I'll then go through ways we might want to overcome these processes if we do. And then I'm going to end on kind of the larger question, which hopefully we'll discuss a little bit, is what should we even actually be expecting of citizens? And so the talk draws on 5 different papers, so I'm going to be glossing on the details, but hopefully it'll be clear enough for everybody. So let me start with just these 3 realities I mentioned. One is media saturation. So this was from 2013. Americans spend 11 hours a day with electronic media. That same study estimated by 2015, this is where we are right now, is that they will consume on average 15.5 hours per person a day. I'm not quite sure how that's even possible. I guess people don't sleep a lot, but clearly there's kind of media everywhere, and that's accelerated at a pace that we've never seen before. Second thing is well known to all of us is partisan polarization. And if nothing else, we know at the elite level within Congress there's been a polarization of politicians, and this carries over into policymaking and on scientific matters. So this was the day after the 2010 midterm. Obama said on energy issues we're probably going to have to say there are some issues where there's just too much disagreement to get things done right now. And then the third phenomenon that I'm talking about is the politicization of science. And that's a term that's used in a lot of ways, so I'm going to be very specific by what I mean by it in this context, and that is exploiting the inevitable uncertainties about aspects of science to cast doubt on science overall. And so an example of this In May 2014, there was a consensual report on human-induced climate change that had representatives from 3 oil companies and went through 80 scientists, the National Academy of Sciences, and it was a pretty consensual report. Next day, the front page of the New York Times, this is what was quoted by Marco Rubio. "I do not believe that human activity is causing these dramatic changes to our climate the way that these scientists are portraying it. I think the scientific certainty that some claimed isn't necessarily there." So again, the idea is just introducing that there's uncertainty. And there is always uncertainty of science, so it's a pretty easy thing to do inherently with science. Okay, so what are the consequences of these? So I'm going to go through each of these contexts, and I'm going to talk about how that might affect opinion formation. So the first is media saturation. And really, here I'm just thinking of general information saturation. And so I'm going to talk about a study, not that I did, but I'm going to build on later, but a study that was done by these authors from Columbia that looked at the availability heuristic. So what is the availability heuristic? It's when a basis for judgment is cognitively available, that is the ease with which it comes to mind. So for example, a lot of us overestimate the likelihood of dying in a dramatic event, such as a tornado or terrorism, compared to a mundane event. And so we might overestimate things because they come to mind easily. So think about climate. What comes to mind easily? Today, right? Today's temperature. So today feels very warm, right? It feels pretty warm, at least to me it does, living in Chicago. And so what happens here? And so this study, I'll talk you through this because it's probably not immediately apparent. The idea here is that people, there we go. So the idea here is that how you feel today affects how you think the weather's been over the past year, which then affects your belief in global warming and how important global warming is to you. So what these authors did in this study is they basically asked people, how much warmer do you think it is today? And what you can see is as people thought it was more warmer today, just today, they thought there were more, so the y-axis is the percentage of days that were warm, over average warm in the past year. So the warmer you think it is today, the more you think there have been more warm days over the last year. And then the lines show, as you think there are more warm days over the past year, you have a greater belief in human-induced climate change, and you think global warming is a more salient problem. So that's the causal mechanism. Basically, the availability of today's temperature drives your beliefs in global warming. Okay? So that's overflow of information, you use what's available. So that's the first dynamic. Second dynamic is partisan motivated reasoning. So what is that? What exactly am I talking about? I'm talking specifically about directional motivated reasoning, where that's the tendency to seek out information that confirms, in my case, prior partisan beliefs, and view evidence with prior opinions as stronger regardless of the objective accuracy of that information. So for example, a Democrat's going to view a policy that comes from Democrats as more effective, you're going to be more likely to support it than if that same policy came from Republicans. Okay, so how is this going to work out in a polarized environment? So there's a survey experiment that I did with some co-authors, and the focus was on drilling, and everybody was told that the Republicans support increasing drilling and Democrats oppose it. It was a representative sample, and we did this in 2011, and only with partisans, or at least leaning partisans. So everybody heard that Republicans support, Democrats oppose. So they were then assigned within conditions to either a polarized or a non-polarized prime. So the non-polarized prime kind of emphasized how actually the partisan divide is not that stark, and parties are not that apart, and you can find points for compromise. Whereas the polarization prime reminded people that the divide is actually quite stark, and most members are on different sides. They're on the same side as their own. There's homogeneity within parties and heterogeneity across parties. So people got one of those two primes, and they got different types of arguments. So they all got an argument for drilling and against drilling, but the quality of those arguments varied. And by quality, we pre-tested to see what was a strong or a weak argument. So they got some mix. They got either a pro argument that was strong, that emphasized the economic benefits of drilling, or a weak one that talked about how drilling can lead to other technological developments, or they got a con-argument that either focused on worker or maritime safety, and that was strong, or on regulation. Okay? So basically, it'll be clear when I show you the results in a second. Everybody heard Republicans support it. They either got polarized or non-polarized, and then they got some mix of arguments that were strong or weak on each side. So what happened when people were in the non-polarized conditions? This is support for drilling. So what you see here, what I'll bring your attention to, is so this is where they got a pro-strong argument and a con-weak argument. Okay? So what you even see here is the blue bar, so that's Democrats. Okay? They don't care that Republicans, or I shouldn't say they don't care, but the fact that Republicans were the ones who endorsed drilling did not matter as much as that they got the strong argument in support of drilling opposed to a weak argument. So the quality of the argument mattered here, the perceived quality of the argument in the non-polarized conditions. Okay? So that's not partisan motivated reasoning. Okay? What happens when people were primed by the polarization cue? Okay? You can see. Suddenly, whoops, or you can't see, there you go. So suddenly, the perceived strength of the argument is not so important, but rather people are going with, if you're a Republican, you follow the Republicans. So you can see here, Republicans always support it. So they even support it when they get a weak pro-argument. And Democrats, if they hear Republicans support it and Democrats oppose it, they follow the partisan. So again, the consequence here is polarization increases partisan-motivated reasoning. And so what are the consequences of that? I'll get to later. So let me get to the third thing, which is the politicalization of science, which I defined before. And what happens here is that can introduce a status quo bias. And by status quo bias is what it sounds like. It basically, you favor maintaining the status quo to changing things. And often a dynamic underlying this is if there's uncertainty introduced about the future, you want to stick with the status quo. And that's the mechanism that I think politicalization of science may work. It introduces uncertainty about science, and suddenly you're not sure if you should believe that science, so you don't want to make a change. And so we did a study of this with some co-authors again, and here the focus was on support for using nuclear energy. This was in the summer of 2010. And there were two experimental factors here. One is you got information. You either got no information, so all the information was in favor of nuclear energy in this experiment. You either got no information that talked about how nuclear energy is relatively better for the environment than classical uses of classical ways to get energy, or you got that frame, but also scientific evidence that said, yes, we can store nuclear disposals safely. And then so they were assigned to one of those information conditions, and then they were also assigned to a prime that either politicized it or not. And so the one that politicized it basically told people it reminded people science is politicized and people use it to their own political ends. So what we're interested in is what exactly did introducing that politicalization do to the impact of that scientific information. And what you'll see is, in the first two bars, this is percent increase relative to a control group for building nuclear energy plants. And what you see is when people got the information with or without the scientific evidence, their support for using nuclear energy increased. But as soon as you reminded people, like, we don't know what science we can believe, that not only canceled out any of the positive impact of that scientific information, but it actually led to a slight decline in support overall for nuclear energy. So what we see then is across these three dynamics, we see three opinion formation processes that might be troubling to some people. I'll get back to if they're troubling or not. But in the literatures, a lot of people see these things as troubling, right? So the availability heuristic, this was a quote talking about the study that I showed you. In fact, it was a commentary on that study. It's a discovery that should trouble anyone interested in engaging in the public in a thoughtful debate about global warming, polarization, and motivated reasoning. Here's a quote that's talking about the same kind of dynamics. The process of biased assimilation of information can lead to a set of beliefs that are strongly held, elaborate, and quite divergent from scientific consensus. And then it's kind of the same dynamic with the politicalization of science. Suddenly, science is not used in a way that scientists think it should be used. But I'll get back to that quote in a second. Okay, so the question is, are there ways to overcome these processes? At least in theory, are there ways to counteract them? And so I'm going to talk through three studies that look at that one at a time. So the first is taking that same experiment, okay, with today's temperature and seeing what happens if you interrupt that availability process. That is, today's temperature comes to mind easily, but what happens if you interrupt and make something else come to mind easily? So this was just so today is a great day to talk about this, right? So today you might think, gee, it's really warm at Chicago. It's April. I've been here at the Midwest other years, and it's been freezing. And so you think suddenly, oh, it's warm. It's been warm over the past year, and then the dynamics that I talked about before. So this was basically an aim to replicate that study with one caveat that I'll talk about in a second. It was done on September 29th, 13 miles away in Evanston. It was a very warm day. It was 80 degrees, which is above the normal, and in late September, that's particularly warm. And it was useful for me that the prior winter was the coldest it had been in 30 years. So that was not easy. That was easy for people to remember if they lived through it, because it was notably cold, and schools closed, which is unusual. So people were randomly assigned to one or two conditions. One was the non-prompt condition, which was just a replication of the study that I showed you before, wherein I just asked perceptions of today's temperature, how many days do you think were warm in the last year, and then your beliefs about global warming. And then there was another condition where I just added, when asking people about how many days there were over the past year, I just reminded them about last winter, right? I just said, consider last winter compared to today. Thus think not only of your feelings today, but also how you felt throughout the year. So I'm basically interrupting that availability process. So this is the ugliest thing that I'm going to show you, so I'll talk you through it. But basically what that prompt did is it severed the tie between your perception of today's temperatures and your global warming beliefs. So to look at this most directly, if you just look at the correlation between your belief in global warming, that there is global warming, and if you think today is particularly warm, In the non-prompt condition, just like in the original experiment, you see a significant correlation, but with the prompt, that was severed. And the same thing for the salience of global warming. Interestingly, if you're still paying attention and following this, the percentage of days you thought were warm last year still was affecting your opinions about global warming. So what was happening with the prompt, it was interrupting the correlation between today's temperature and how many days you thought were warm last year. So the percentage of days warm last year was still affecting things, but the availability of today was suddenly no longer affecting. So you can't overcome that in the sense that at least today's availability doesn't have to matter. Okay, what about partisan motivated reasoning? One way to overcome that would be to induce people to think through the policy by inducing accuracy motivation, or if you can offer them a cross-party endorsement. So this was an experiment on support for the 2008 Energy Act. And for those of you who aren't familiar with the act, it was an act that required, it was a big act, but three things it did. It required automakers to boost gas mileage, it provided funds for the development of global and geothermal energy, and it also provided small business loans. So it was kind of cross-partisan in that sense. And so there were two experimental factors. One was the endorsement. Okay, so you either told, and all these things were true actually. You either told the Democrats widely support, or it was supported widely by Democrats, which was true. It was supported widely by Republicans, which is true if you just look at the House, and Bush signed it. Or it was supported by some, but not all representatives of both parties, and that's true too. So they got one of those three endorsements. Okay. And then there was also, they were either just left alone or they were prompted to think through the policy. And that was, we just used a psychological prompt where we told people that they're going to have to explain why they hold the opinions they do later on. So the question is, does the accuracy prompt or the cross-partisan endorsement minimize the impact of partisan motivated reasoning? And what we found is in the circled, those are the circled effects, is what you find is, yes, when you get a cross-partisan endorsement, or even if you got a partisan endorsement, if you were induced to form accurate opinions, suddenly you look exactly like people who just got the information about the policy with no endorsement. So that severed the impact of partisan motivated reasoning, either by inducing the accuracy prompt or getting cross-partisan cooperation. Okay, finally, the politicized status quo bias. How can we counteract that? Well, what we can do is we can offer people a warning before something's politicized, or we can do something later after it's politicized by correct them, right? And this comes from a very old literature in psychology on inoculation, and then more recent work in political science on corrections. But basically, what happens if you tell people the information you're going to get is not accurate, or the information you got wasn't accurate? And so we looked at the impact of that, and here we're looking at support for fracking and support for carbon nanotechnologies. And it was very much like the experiment I showed you before on nuclear energy. So there was a strict control condition, a condition that offered an argument and evidence, kind of like on one of those technologies, like the nuclear energy one. But in this case, and then there was a politicization condition. But in this case, the interesting conditions were very early in the survey, and then there was lots of stuff in between. They were given a warning where they were told later, people try to politicize this technology, fracking or carbon nanotechnology, and the scientific consensus is that there is a scientific consensus and it shouldn't be politicized. Or they were told that after they were told that it had been politicized. So it was either a warning or a correction. So the question is, do that warning or correction counteract the politicalization effect that I showed you before? And the graph is a little different, so I'll talk through it real quick. So this is the control group. This is just their average support for the technology on a 7-point scale. So in the control group, you see they're around 3.8 for both technologies. And then in the, when they get evidence or in support of the technologies, not surprisingly, they become more supportive. If they're told it's politicized and nothing else, just like nuclear energy, support decreases. The impact of that evidence disappears, support actually decreases. But the warning in particular and the correction to a lesser extent minimize the effect of that politicization. So if you can get in there before something politicized, you can prevent that from having an effect, or if you get in there after, you can at least limit it a little bit. Oh, okay. So that's not very useful. I'm not even sure what that said. I think I was just basically summarizing. So basically you have these three dynamics that are happening in the political world. In many ways, they might cause things that might be troubling to people. There are ways to overcome them. Of course, these raises a lot of larger questions, which I think that slide, so I get to this slide. One question that I'm sure occurred to most everybody as I was going through those counteractions, are those even realistic? I was really looking at, is there ways to do this? But in the communication environment, can we really offer warnings before politicalization occurs? Can we really get bipartisan endorsements? And can we really, I actually think the availability one is the most realistic of the three. But that begs another question of which we don't have a lot of information about actually, is what does the scientific rhetorical environment look like? And I don't think we have a great grasp of that in and of itself. On different technologies and when it comes to different scientific questions, what are the communications looking at that people are getting? So that's a question that I think we need to explore. And then I think we have to recognize that the solution here, and at least the results that I'm showing you, the solution is not to provide just scientific information. So insofar as you were troubled by those three things and that you found the solutions better, more salubrious in some ways, notice none of them involve providing people just with more information per se. So the solution is not really to just change is not just to provide people more and more scientific information, but it's to change the quality and the nature of the communications, and then insofar as people can become motivated, engage them more in the scientific decisions. And that can be done by localizing scientific issues to some extent. You might be able to get some more motivation. But then there's a larger question, right, do we even are those corrections really improvements? And that's a larger normative question of how do we even assess opinions without imputing values? That is, do we even want or need those solutions? What's the relevant counterfactual? So when it comes to, just like when it comes to most political opinions, when it comes to opinions about scientific issues, it's kind of the same problems. What is the relevant counterfactual? And often used relevant counterfactual is what do scientists think? But scientists, why should that be the relevant counterfactual? They're susceptible to the same kinds of reasoning errors, and so on and so forth. Or you might say it should be what scientific evidence, the consensus scientific evidence. Well, on most scientific issues, arriving at a consensus is not easy to do. So climate change is an exceptional in that case. But even there, obviously, there's some dispute. So what is the counterfactual that we should be thinking about? And then we need to think about how to assess that. And we need to think about the specific person, consider the processes at work. So that's what I tried to show you today, some of the processes that might be at work, and then think about the values that people hold and avoid imputing them when we start to assess their opinions. So that's it. So I welcome any questions and input.
Thanks for your talk. So a couple of questions in the context of a case study that's in the news recently. It seems to me that the issue is nobody really accepts causality, right? Because my facts are different from your facts and my facts give me some link. So how would you speak to this in the context of what was reported last week or the week before around fracking in Oklahoma, which has gone from 2 earthquakes a year to 830 some? Now, again, that's not good news for core industries in Oklahoma and significant chunks of job creation and income and mobility and all that. So, I mean, is that a good case study to use to talk about how this issue might be played out in terms of facts and causality?
Yeah, I mean, I guess the question, I think there's the larger question that I was trying to get at the end is kind of arriving at those facts is not an easy thing to do. So even looking within the scientific literatures on these different technologies, the question is there agreement on what those facts are? And then even if there are, how do we communicate that? And giving people kind of the detailed scientific information and kind of the causal mechanisms underlying that scientific information is probably not going to be particularly effective. So what would be effective is having scientists try to find a way to work towards some kind of state of consensus in exactly what the science is, and then think about ways to communicate that. And so what I've not done is figure out exactly what are the best ways to communicate that, but I think what I've showed you is that it's very easy to impugn if you just try to say, here's the scientific evidence, right? Because all you have to do, it's very easy to just say, there's uncertainty, and suddenly people are like, I'm not sure what to believe. So the threshold for kind of getting scientific evidence, if you want, first you have to agree on that scientific evidence. And so I don't think within scientific associations there's enough attention to how do we even arrive at that scientific consensus, or what does that even mean? And then the second thing is communicating that. And I think the challenge is it's very easy to minimize its effect, so we have to think about ways to communicate it with that in mind. So, right, I talked about warnings and corrections. That, outside of my survey experiment, that's going to be hard to do, because as soon as something becomes in the news, it's something you're going to get these warnings and corrections all over the place. And I didn't really look at that. This was just kind of the upper limit of what you can do. So I think that there's 2 points. One is, what are the facts? And I'm not sure we even know in a lot of those cases. And I think scientists have done a poor job on that front. And then how do we communicate that? I think I know what not to do, but I'm not exactly sure what to do.
Thank you very much. I first had a little question about your title, because it seems to suggest that if we just got the politics out of science communication, everything would be cool. But that doesn't really fit with the substance of your talk. To ask, do politics hinder scientific communication seems a little bit like asking whether water hinders fish from swimming. And what you really gave us were suggestions on how to not get rid of the politics, but how to change the politics. So that's just one comment. And then I had a more specific question. I wonder if the way that you're framing this is putting too much emphasis on scientific uncertainty as a causal factor. There's a lot of sociological research that shows that more important factors about whether people trust scientific advice has to do with whether they trust the institutions and the people that are providing it. And there are examples like the ozone case where there was actually huge scientific uncertainties. While the issue was being put on the public agenda, Congress initiated legislation after the very first studies, and further studies actually increased the amount of uncertainty about the ozone hole. But because the issue was not bound up with the extensive economic interests that the climate change issue is, people were more willing to move forward despite the scientific uncertainties. So I wonder if you could say a little bit about how you see the role of scientific uncertainty in relation to other variables that affect people's trust in science.
Thank you. That's a lot to think about. A quick comment is trust actually in the first study on politicalization, it actually didn't moderate the impact. I didn't show those results. So there's an interactive effect. I can't, given the nature of the study, look at the relative impact of those factors, but my immediate reaction is your example is really interesting because my immediate reaction is uncertainty plays into trust in science, but your example demonstrates that how that plays into trust in science is going to vary by the specific science at work. I think I guess your point is very well taken, and I think trust in science is obviously still pretty not well understood. You know, I used to have a slide that I took out actually that showed trust in science trends over time, but those are so disputed that I took it out because I'm not sure what the trends are. You know, if you're probably familiar with that debate in sociology from the 2012 ASR article. But I think, I mean, basically, I appreciate your question because I think I need to connect the politicalization stuff to more than how does that affect trust in science, because that's ultimately what's going on. And is that a blip or is that a long-standing thing by issue area? So, and fair enough on the title.
Jamie, I've got two for you. The first, are you seeing any differences in your results across the content or the specific scientific questions we're talking about? And I'm noticing, just looking at your bar charts, that if you give them disarming information, the partisan frame goes away, the evaluations change. Does that matter with content? And the second question is, how do you fall on the question of whether the partisan frames are actually informationally valid? You know, I'm thinking about how science is writing the NSF budget for next year, and they just gutted social science spending, at least in the chairman's mark. And I imagine if you had an experiment where you said, you know, Republican Chair Lamar Smith yesterday proposed huge cuts in social science, people are going to seize on the party label. If you said, well, there's a big debate about this, and 9 out of 10 scientists feel social science research is incredibly important, you'd get a different result. But I don't know whether that's taking away the partisan frame. You're kind of privileging the quote objective unquote information. I mean, maybe Republicans just don't like funding political scientists, and that's as much of a truth as anything else.
Yeah. So, I mean, I think your second question was really a great point, more than a question in a way. Insofar as I think and it's kind of what I was trying to get at and getting discussion at the end is exactly what do people want. So, I think there's a billion things written on climate change, and one of the best articles I've read shows that Republicans, if you look at the data, right, everybody says, well, Republicans don't believe in climate change. Actually, they pretty much do. What they're averse to is the policy implications of that climate change. And so they don't want to say they believe in climate change when they're asked because they worry about what that will do for policy. And so and I think that can be true on a lot of different scientific issues, and something that we've only, there's probably 10,000 articles written on climate change opinions, and this is a recent article that just made this point. And I think it's a powerful point, and I think that kind of is what you were getting at with your second question. Their first question, yes, it does. So it does vary by scientific technology, and so climate change is going to be an issue unto itself. We did the similar experiment on the politicalization and the warnings and corrections with climate change, and we haven't analyzed the data very much yet, but I'm pretty sure from looking at it very little bit, it's very different. Right, this is an issue of kind of, as political scientists endeavor into this area, it's a general question for political scientists, how do we choose what scientific issues to look at? That's a big question for all of us all the time when we're studying public opinion on issues, but it's particularly relevant here because it's, right, I did carbon nanotechnology. Nobody in the survey had ever heard of that before. So what does that mean? So what does that mean of the generalizability of the dynamics? If I used climate change instead, it would have been different. So, they're both very important points.
Thanks, Jamie. Given that it's the non-polarization prime that seems to be trumping partisan-motivated reasoning when it comes to the first scientific issue that you were looking at, I wonder if you could show observationally that issues where there's less polarization, there may also be greater trust in science. Have you seen any evidence of that? I mean, I can't particularly think of issues where there's less polarization, sadly. Maybe vaccines, I don't know.
I don't know if people have asked the issue-specific science questions enough, right? So you'd have to say, do you trust science on this issue?
Right.
So Dan Kahan, he does have that paper where on issues that are politicized in a partisan sense, what you see is as people get more information, they polarize. And so on climate change and fracking, and I can't remember what his vaccines maybe, don't quote me on that. He looks at across like 20 different scientific issues. And on those three, as information increases, polarization increases, regardless of the science, right? So, but on the less politicized ones that you don't attach to the parties so quickly. I think he had nanotechnology in there. So nanotechnology, you don't see that. So that speaks a little bit to the question. But I don't know, I've never seen that somebody actually use science-specific trust questions. But it's a good, it doesn't mean they haven't, but it's a good question of if trust in science should be issue-specific. Because that gets back to the question before about there's a huge debate about how to measure trust in science.
I just think that first finding you presented really does suggest that trust in science will be issue-specific depending on the level of polarization.
Yeah, I assume that it is issue-specific. It's at some level.
Hi, really interesting overview. I'm curious what sort of response you might have had to the underlying work that you're summarizing here from actual working scientists or science organizations, or for that matter, science writers or journalists. People who are in the business of trying to figure out how best to communicate science to the public. What do they have to say about this?
Yeah, I guess two answers. One is it's an uphill battle to engage scientists a little bit, so I'm trying to do that more. And so it's been hard to get a lot of response. Locally in my own institution, I'm doing that more. Next week, actually, I'm having a meeting with them, and so, I don't know on that science front. With science writers, not a lot of reaction. The largest reaction I've gotten is whenever I've presented any of these things to public audiences, there's usually a negative reaction because they don't like that I'm doing experiments on some kind of science that they might oppose. So it's an interesting observation when you go into, right? So when I presented the nuclear energy results that I showed you, so, I presented that at least twice where I presented to fairly public audiences, and you know, there was one person or a few people in both those audiences who were irate because they thought I was pushing people to endorse nuclear energy. So I think, I mean, it's an interesting question. I mean, because it's made me think about this kind of, you know, in general, when we do experiments, you're moving people, or you know, there's debriefings, but, you know, it makes you think. But that's the largest reaction I've gotten so far. But it's hard to, you know, I think we'd all benefit a lot if we could engage scientists more. It's not easy, though. And they, to the extent that I have, they're usually like, let's just give people more scientific information. And they're kind of incredulous and mad that that's not really how things seem to operate in people's minds.
We have time for one last question.
Jamie, very interesting presentation. There have been a couple other talks in this series, in this room, that touch upon somewhat similar dynamics. I wanted to get your reflections. First, but a question on your title.
It's a bad title.
Okay. Why do you use plural politics as opposed to does politics? But more specifically, Theda Skocpol talked about the politics, understanding politics of Obamacare, and the understanding or misunderstanding of both what it does and what the public attitudes are very much confused in terms of the, you know, the political controversy. And then Jennifer Hochschild talked about genomics early on and similar sort of dynamics of what people understand and don't understand. So I'm wondering if you want to reflect on your approach on those two additional quasi-scientific topics.
Yeah, I mean, I guess this kind of gets back to the first question in terms of arriving at what those facts are. I mean, it kind of, to me, I mean, it's a nice, good for our last question because it kind of summarizes the question of arriving at what those facts are, which I think as a scientific community, we're not doing a good job. And that includes political scientists and kind of any association. There aren't really steps in place to recognizing the consensus. But then even if you did that, how do you communicate that thinking about policy? And this kind of gets back to Bill's point. So people might know a lot, and kind of Samara's question, you give people more information and they become more knowledgeable about the science doesn't mean that they're going to go in the direction that the science thinks they should go, right? So the example of climate change, as Republicans get more, if they get more scientific knowledge, they become more opposed to climate change. And so what's going on there is that there's probably policy solution aversion. So, you know, the points are, one, arriving at that scientific information, and then what you think that scientific information should do might not be what it does do, and you should ask the question of why do you think it should do what you, there's a normative value when you start to push the science suggests this in terms of policy. So we have to kind of separate policy from the science. So there's a lot of, I think there's a long way to go. We have to identify the scientific consensus better, and then we have to think about the connection to that and policy. And that there's a step in there that a lot of people seem to miss.
Well, thank you all for coming and for your great questions. Please join me in thanking Jamie Druckman for his talk. All right.